So what's going on? First of all, why did the pennies look dirty before we put them in the vinegar? So as we know, everything around us is made of tiny particles called atoms. And some things are made out of just one kind of atom. For example, copper is the atom that makes up pennies. But sometimes atoms, as we know, can react and combine with other atoms to form molecules. So in this case, we have copper that reacts with oxygen in the air and it produces copper oxide. So what you're looking at on a really old penny is a coating of copper oxide that's been created. So why does vinegar and salt clean the pennies? Now, vinegar is what we call an acid, which is what we'll be learning about over this next unit. And the chemical formula for acetic acid is CH3COOH. And we call that acetic acid. And the thing that all acids do is they take hydrogen atoms and they make it really easy for hydrogen atoms to dissolve in liquids and create what we call a hydrogen ion. So hydrogen ions are really what's responsible for all acids. Now, acetic acid is very weak, so it wouldn't do the job totally by itself that well. So what we also did was we added salt. And as you know, NaCl is the chemical formula for salt, and it dissolves in liquids to form sodium ions and chloride ions. Now, what happens to those chloride items is that they can also bond with chloride and they form HCl, which is hydrochloric acid. HCl. So hydrochloric acid can also dissolve. So we actually had two acids in here that were working to dissolve that copper chloride. But in the end, they both do the same thing. They just produce hydrogen ions. So we looked at these unrinsed pennies and we saw that they turned this unique shade of blue and green. So why did that happen? So copper oxide dissolves in a mixture, when the vinegar and salt actually dissolve the copper oxide layer, they make it easier for the copper atoms to join with the oxygen from the air and chlorine from the salt to make a blue-green compound that we call chlorite. And chlorite is an insoluble salt, which is something that you might remember from the solubility experiment that we did. Anytime you mix something with copper, you got this bluish color, and it was always insoluble, the salts that we created. And that's essentially what happened here. We allowed some of that chloride to stay behind with the copper to create copper chloride, which is part of the formula for malachite. So when we put this in an acid, it allowed all of the copper to dissolve. So how did the nail and the screw get coated with copper? So to understand how the nail and screw got coated with copper, you need to understand a little bit more about atoms. So we know that atoms are made of protons, which are positively charged, neutrons, which are negatively charged, and electrons, or neutrons are neutrally charged, electrons are negatively charged. So negative charges, as we have learned in class, attract positive charges by Coulomb's law, opposites attract. So when you put your dirty pennies in vinegar and salt, the copper oxide and some of the copper are going to leave the penny and start floating around in the liquid. But when these copper atoms leave the penny, they're going to leave some of their electrons behind on the penny. So rather than having all of the copper atom in the liquid, you get copper atoms that are floating around that are called copper ions because they have a positive charge, a 2 positive charge. Because they're missing 2 electrons. Now, when we add these steel nails and screws to the mixture, steel is a metal that's made by combining iron, some other metals, and carbon. So as you found out, when you cleaned your pennies, the mixture of salt and vinegar is really good at dissolving metals and metal oxides. But when you put the steel nail in the mixture, some of the iron also dissolves. And like the copper atoms, each of the iron atoms that dissolves leaves 2 electrons behind. So you've got positively charged iron ions floating in with your vinegar, and also positively charged copper ions. Originally, the steel nail was neutrally charged, but when the iron ions left their electrons behind, the nail then became negatively charged. And remember what I said just a minute ago, negative charges attract positive charges. So the copper ions are more strongly attracted to the negative charge than the iron ions are, so they stick to the negatively charged nail and form a coating of copper on the steel. So why did bubbles come off of the steel screw? So each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. In an acid, like acetic acid, or vinegar or lemon juice, there are lots of hydrogen ions floating around. So the chemical reactions at the surface of the screw are some of those hydrogen ions joining to form hydrogen gas. These are the bubbles that you saw coming off of the screw. And if you'll recall, we've also done labs where we've used hydrochloric acid, which is what was formed. And that created our bubbles. Okay, complete the lab handout, answering the questions based on what you've discovered from the lab, and turn in by Tuesday at midnight. See you guys later.